Okay, one final example to finish this section on arithmetic sequences and series. This problem says that the sum of three consecutive terms of an arithmetic sequence is 48. So as soon as I see that, I'm thinking that I'm going to need three spots. The sum of their squares is 786. Find the three terms. Hint, let x denote the middle term and d the common difference. If x is the middle term, then the term after that would be x plus d. The term before the middle term with a common difference of d would be x minus d. I have two variables and I have two pieces of information, so I'm probably going to write two equations. The first one says that the sum of the three terms is 48. So I can write x minus d plus x plus x plus d. Here's the first term, here's the second term, here's the third term, is going to equal 48. Well, luckily the d's cancel, and I'm left with 3x equals 48. X equals 16. So I know that the middle term is 16, and all that's left to find is d, the common difference. If the sum of their squares is 768, I'm going to need to take these three terms and square them. So the first one, that's my phone ringing. I'm not answering it. To find the common difference, I'm going to use the second statement that says the sum of their squares is 786. I know that x is 16, so the first term becomes 16 minus d. But if I want to sum the squares of those three terms, I'm going to square that. Plus, I know that x is 16, I'm going to need to square that. Plus 16 plus d squared equals 786. Solving this for d is going to take a little bit more work, but again, hopefully lots of things will cancel out. 16 squared is 256 minus a negative 16d and a negative 16d totals to a negative 32d plus d squared. I've got another 256 from the middle term right here. And then the final binomial squared is a third 256 plus 16d, and 16d is 32d plus d squared equals 786. Again, some stuff cancels out. Negative 32d and a positive 32d disappear. I've got a d squared and a d squared for two d squareds. Done with those. 256, 256, and 256 is 3 of those 256s. I don't want to try and add that in my head, so I'm just going to postpone that a little bit. To solve this for d, I'm going to subtract 3 of those 256s over to the other side. 2d squared equals 786 minus, and now off to the side, without using a calculator, I'm going to try and figure out what 3 times 256 is. Well, I know that 250 plus 6 is 256. 3 times 250 is 750. 3 times 6 is 18. So 750 plus 18 is 768. Subtracting the right side, I get 2d squared equals 768 from 786 is, I think it's 18. Divide both sides by 2. D squared equals 9. And we get D equals plus or minus 3. And the next challenge is to figure out whether I'm going to use a positive D or a negative D. Well, when I look back at my three squares, a positive or negative difference would work. I'm going to fill in the middle square with 16. And if I make my D positive 3, this is 19. And the first one is 13. If I decide that my d is negative 3, that means that my sequence is going to decrease by 3 each time. So I'm going to put a 16 here, a 13 here, and a 19 there. So I've got two possible answers. Both both of which are acceptable. The sum of those three terms for both of them is 48th, and the product of 13 squared, 16 squared, and 19 squared is 7/68. So that's it for arithmetic sequences. The next section will go over geometric sequences and series.